6.3, we're going to talk about halogen and noble gas. So for group 7, okay, it is called halogen. So for halogens, okay, the first member is fluorine, and then we'll go to chlorine, bromine, iodine, and acetylene, okay? So pay attention, okay, to their color, because you find that all of them, they will have different color. And the colors, it just go darker when it go down to the group. So for fluorine, it will be pale yellow gas. And then next will be chlorine, it will be more green, okay, greenish yellow. And then we'll go to bromine, which is reddish brown liquid, okay. Pay attention, the state of it change from gas to liquid. And afterward, it go to solid. Lastly, okay, we'll just have black solid, okay, for the iodine and acetylene. Okay, so all the color is very important. And in the electronic configuration, you'll find that all of them, they will have 7 in the outermost shells. So therefore, it belongs to group 7 halogens. And because all of them, they have 7 outermost shell electrons, but do remember they have different electronic configurations. So, or at most, we can only say that they have similar chemical property, because again, they will have different degree in the reaction. So the similarities of group 7 elements, all of them have colored like what you have seen, and then the other one will be all of them are very reactive. And one thing I want to add on is about the poisonous. All of them are poisonous. So when you try to deal with these chemicals, okay, better to do it in the fume cupboard. Okay, and then this is a kind of non-metals elements, okay, because it's on the right hand side in the periodic table. This is group 8 or group 7, group 8 or group 0, and then group 7 is right here. So they are on the right hand side, so therefore all of them, they are non-metal. So for non-metal combined with the metal one, they have an ionic compound, okay, like what we've mentioned before, like NaCl, like KBr, okay, like many other kinds of combinations. Say, for example, you have like magnesium, fluoride, things like that, okay? So all these are called ionic compounds, the combination of metal plus non-metal. But actually, it can also form something called covalent compound, okay, within non-metal elements. So when you have non-metal elements, say, for example, you have H, hydrogen, and also chlorine, you put together, you form hydrogen chloride. And also you have other kind of non-metal combined with these. Say, for example, you may have NaCl3, which is nitrogen trifluoride. So all these, okay, when it combined with between two non-metals put together, we call those covalent compound. If you have a metal and a non-metal combined together, we call those ionic compound. So for the chemical properties, okay, all of them, they will react with hydrogen, but this is different from the group 1 and group 2 metals, okay, because you see that, okay, fluorine, the first member, they react explosively. Okay, even in the dark, that means you don't need to have extra UV, you don't need UV, you don't need to have light, okay? They will react explosively. The hydrogen and the fluorine, they will react together. Something like this. And for the chlorine, okay, they will also react explosively. But this time, okay, in the dark, they cannot. Okay, they have to do it in the sunlight. And for bromine, okay, even in the sunlight or heated, okay, they may have reaction. But finally, you find that iodine, they have no reaction, even in direct sunlight. So even you provide energy to it, okay, the iodine will not be reactive enough to react with the hydrogen. So you see that the reactivity, they will decreases down the group. Okay, so to sum up, okay, you'll find that, okay, this is group 0, noble gas, okay. The one on the left-hand side, the more you go down, okay, the more reactive it is. But on the right-hand side, the non-metal one, okay, that is the halogen one, okay. The one above, okay, the first few members in a group, okay, they will be more reactive than the lower members, okay. So we see that the reactivity decreased down the group. And for group 8, okay, sometimes we call it group 0 as well. We call those noble gas. Do pay attention to spelling, okay? Don't spell it wrong as Nobel, okay? And for noble gas, okay, we have helium, neon, argon, krypton, xenon, and radons, okay? All of them, okay, they are colorless. They are colorless gas, okay? All of them, they are gases at room condition, okay? Pay attention to that, okay? At room condition. And then you'll find that, okay, the electronic configurations of them, okay, it is not must be 8 in the outermost shells, because we do got an exception here. Okay, because you find that, okay, the first shell can maximum hold 2 electrons. So therefore, you'll find that helium, it won't have 8 electrons in the outermost shells. Okay, so this one is very important. If a question saying that, okay, all noble gas must have 8 electrons, then this statement must be wrong. Okay, because we do have exception, that is helium. And for similarities of the noble gas, okay, you'll find that all of them are colorless gas at the room conditions, and they are called noble gas because they act like a noble. Okay, they are very unreactive. Sometimes we call that inert. Okay, they're not reactive at all. Okay, they have no reaction with other elements. Strictly speaking, this is not absolutely correct because some of the lower members of noble gas, they may have reaction with others. Okay, but in your level, okay, just consider that there is no reaction with other elements. This one is not in your textbook, but I think it is also very useful. It's talking about the uses of noble gas. So for helium, okay, we'll use it to fuel the airship. Just pay attention, helium is very, very light. So therefore have a low density, it can float in air. Okay, so the balloons, okay, that you have, okay, in the market, okay, those are also filled with helium. Well, long ago they are filled with hydrogen, but of course now we don't use it anymore because hydrogen is explosive. But helium is a form of noble gas, so therefore they are relatively inert and also unreactive. And the next, okay, that will be neon, okay. So all these light, okay, we call that neon light, okay. So we use that to fuel neon light, okay. So pay attention to verb, okay. I need you to add fuel neon light. Last one is the argons, okay. Argons, okay. It is the spacing right here, okay. We fill it with argon, and then the wire here, actually it is this one, okay. Actually this one is tungsten, okay, just for information. Tungsten is also a kind of element, okay, have an element W, okay. So it have a very high melting point, so even you pass electricity through it, okay, it will become red hot, okay, very, very high temperatures, okay, it will grow or give out light. But if the inside the light bulb, if you contain oxygen, then it may react with the oxygen. Therefore, we shouldn't have any oxygen in it. Okay, we should provide a inert air environment, okay, for the tungsten to grow hot, but without burning. So for argon, okay, used to fill light bulb. So the stability of the noble gas, why it is so stable, okay, because it's all because of the electronic arrangement. Stability is something also related to the chemical properties. They just simply have no chemical properties. Why they don't have chemical properties? Because of the octet structures that they have. So now you can have a look right now, okay, except heliums, okay, neon, argon, krypton, xenon, and radon, all of them have 8 electrons at the outermost shells, okay. So if you remember, okay, if you have 8 outermost shells, okay, in the shells, okay, they do like this. Okay, so most of the atoms actually they try to attain a stable electronic arrangement. That means they have 8 electrons. They want to have 8 electrons. Once they obtain these structures, we call this one octet structures. If they obtain an octet structure, they will have an extra stability. Okay, structure STRUCTURE. Okay, will have an extra stability. So all these, okay, they will have octet structures. But this one, okay, we also have a name for it. It can't be 8, okay, but having 2 is also not bad, okay, because it's already fulfilled the first field, okay, the first electron shell. So we call this one duplex structures. Okay, so this is duplex structures, this is octet structures. So for noble gas, is it a must for all of them to have octet structures? Wrong, okay, because do remember you still have an exception, okay, which is helium that is having duplex structures. So the strong tendency of all atoms to obtain the stable electronic arrangement, we call this one octet rules. Say for example, for chlorine, okay, it is 287. It will struggle, okay, to fight to obtain a stable octet structures. So therefore, what they can do it by gaining 1 extra electrons. If they do so, okay, then the chlorine, okay, we call that chloride because they have extra electron adding in it. They will be stable by then, okay. So let's have a look of class practice 6.3, okay? Right here, okay, you got a sections of periodic table. Explain why lithium and sodium belong to the same group. Same group, okay, basically because they have same number of outermost shell electrons, because group depends on the number of outermost shell electrons. But they have different period, okay, because period we know that it depends on the number of occupied electron cells. So therefore they have different numbers of occupied electron shells. Okay, so state two similarities properties between lithium and sodium. Both of them they are group 1, so you may want to say that they have low density, they are soft, they are physical properties. Okay, remember, don't mention anything that they will react with water or things like that. Okay, so that would be, and then state the trend in reactivity of group 2 elements down the group. Reactivity down the group. Okay, for group 2, when you're going down, they will be more reactive. So reactivity increases down the group. So part D, which metals, okay, in the periodic table reacts more vigorously with water? So remember, okay, right now we are talking about above periodic tables, okay? So therefore, don't tell me something like francium, okay, like rubidium or cesium, things like that, okay? So just right here, which one react vigorously with water? So remember, group 1 and group 2, they will react with water, but the amount that, okay, group 1 is more reactive than group 2. So the reaction is also increases down the group, so therefore K will be the most reactive one, okay? So do remember when you try to explain why it's like that, okay, do mention that, okay, the reactivity of group 1 elements increases down the group, okay. These statements, okay, is very good to help you to explain, okay, which one you think is more reactive, okay. Part E, suggest one reaction shows magnesium and calcium. Okay, we are talking about one reactions here, okay? So therefore, don't tell me anything about the physical properties or have similar chemical properties. So magnesium and calcium, both of them, they can react with, you may say water, but magnesium is not really reactive to cold water, okay? So if you insist to say water, okay, I suggest you to talk about steam, okay, to give hydrogen. But more likely, okay, I prefer you talk about the acid because it is must, okay, for magnesium and calcium to react with the acid, okay, to give hydrogen, okay. So that would be the one that I suggest. Part F, okay, which element, fluorine or chlorine, is more reactive? Remember the reactivity, okay, fluorine, chlorine, okay, and then bromine, okay. Remember the reactivity decreases down the group, okay. So when this go up, okay, this one should be more reactive. So fluorine, okay, will be the one, and the saying will be reactivity decreases down the group, okay. Last one, explain why group 0 elements normally have little or no reaction. So you have to explain this, okay. You have to get back to the stable electronic structures and also the octet structures, okay, in the outermost shells, okay. So pay attention to the words stable electronic structures. So learning the property of the elements in the group, okay, it helps us to predict the properties of some unfamiliar elements. Say for example, right here we have francium and also cesium, okay. We know that, okay, they're coming from the same group, okay. The francium is just below cesium, okay. Francium is here, cesium is here, and those are group 1 elements, okay. So which group, okay, does francium belongs to, okay. So just now we say that it should be belongs to group 1. Which group, okay, I don't expect you to say alkaline metal here, okay. So because if you have to name it is an alkaline metal, they will say name the group, okay, instead of which group, okay. So because it's on the left hand side of the periodic table, they are metal. Okay, and then sodium is a silvery solid. Okay, it can easily cut with knife. Predict the appearance of francium because they come from the same group. You expect that they have similar appearance. So silvery solid must be. Do you think that francium can easily be cut with a knife? They are all coming from the same group. So I expected they also be easily cut with a knife. Okay, and then part D. Okay, cesium react with water, explosive. okay, is explosive reactions, predict the observation when francium reacts with water. But I don't think anything that you can observe because it will be exposed to death. Okay, because francium is lower in the reactivity series. Lower, okay, in the group or than cesium. So therefore, the reaction will be even more explosive. Okay, so we have react with water explosively. Okay, because the reactions increase down the group, so it will be more reactive. This one is very important. Don't just say that it reacts with water explosively, because you have a degree difference. Okay, so you better say that, okay, it's more reactive than the cesium. Okay, last one, suggest a method to store francium. So you can store it under the paraffin oil. Actually, other than that, okay, you can also store it in a Nobel or in a container with noble gas in it. Okay, because noble gas have no reaction with the francium because of its stabilities of the elements. Okay, then next go to class practice 6.4. Okay, so this one you have to refer to group 2. To be honest, okay, the question is more or less very similar. So I recommend you, okay, to go through this, okay, on your own, and then you can find the answers, okay, on the left hand side. To summarize, okay, this video we talk about the group 7, okay, which is called halogen. The similarities of it, all of them, they are colored, okay, they are reactive. Okay, and then they can form with, okay, the halogen, which is non-metal. When they combine with the metal, they got ionic compound. When they combine with non-metal, they give covalent compound. Do pay attention, okay, to the color of these halogens. Okay, the reactivity, they will decrease down the group. So therefore, we found that fluorine is the most reactive one among all of them. And then the color, just how we have mentioned, do pay attention. Remember all the color of that because they give clues what is the elements you're dealing with. Okay, and then group 0, okay, is the noble gas. We also call that group 8. They are inert. They're inert, they have no reactions, okay, very stable. All this because of the octet structures and the duplex structures, which is for heliums, okay, find in the outermost shells, okay, of the noble gas, okay. The uses of noble gas, okay, we have mentioned 3 of them, like argon in the light bulb, helium in the fuel ships, okay. We also use neon to fill up the neon light, okay. So remember the stability related to the octet structures, and octet rules state that all the elements, okay, they tend to have a completely fulfilled outermost shells, so therefore they will gain an extra stability in it. Okay, but remember, not all the noble gas they have octet structures because we do have exception. This one is very important. The exception is helium. They just have 2 electrons in the outermost shells. So that's all for chapter 6. Okay, so you spend some time, okay, to work on the notes and also finish, okay, the chapter exercise at the back. Okay, bye bye.